Good morning. Today we have to discuss about the transport layer functionality and services. So in this video we have to discuss the different transport layer protocols, the different functionality that is associated with the transport layer and different services supported by the transport layer. So our basic discussion will be different processes, services, protocols. For example, transport layer deals with process to process communication. It deals with the port addressing, it support multiplexing, it support error control, flow control, congestion control, and in the transport layer flow control protocols we have to discuss different stop and wait protocols, go back and protocol, selective repeat protocol. These things we have to discuss in another video. I am just focusing on what the basic services and functionality supported by transport layer protocols like TCP and UDP. So this is the protocol stack, TCP/IP protocol stack. The application layer contain different application processes or protocols like SMTP, FTP, Telnet, DNS, DHCP. Transport layer deals with different type of transport layer supports the application layer processes to communicate to the corresponding application layer process through establishing a logical link, and this logical link processing is done by the help of transport layer protocol like TCP and UDP. And this in the protocol stack, the network layer contain network layer protocol include IP, the most popular protocol on the network layer. The error control mechanism network layer is ICMP and IGMP, and address resolution protocol as well as reverse address resolution protocol. And the bottom of the protocol stack support the physical layering and as well as data link, framing, all these things related to the message communication. The transport layer provides process to process communication between the two endpoints. Communication is provided using a logical link connections, which means that application layer assume there is a imaginary direct connection through which the sender can send and receiver can receive the message. So if you can look how the communication takes place between two endpoints, and what we are calling as logical link connection. The application process in the sender side prepare the message, then the transport layer protocol at the sender side receive the message, then it makes some encapsulation like it include header information which contains certain information that we have to discuss during the corresponding protocol like TCP and UDP. And once this encapsulation is done, then by the help of other protocols like IP in the network layer and framings in the data link layer, the information communicated through the physical medium, and in the same process it is received at the receiver. The physical medium receives the information, then it's sent to the network layer. Later you can like the make it the packetization, then it's sent to the transport layer. All these things done, and this two connection between two endpoints is known as logical link connection, and this logical link connection is supported by the help of a socket. So if you have to discuss different transport layer services, so the services supported by transport layer can be divided into basically connection oriented services and connection less services. In connection oriented services, the end user ensure that the information properly delivered at the receiver. It uses different mechanism like it uses sequence number, acknowledgement number to make the packet communication reliable. It uses flow, error and congestion control mechanism. But like protocol like UDP does not use all this thing, but it has other advantages that we have to discuss during the corresponding discussion on the TCP and UDP. In general, the different services and functionalities in the transport layer is like process to process communication. We just discussed how the logical link connection established between the two endpoint. The addressing mechanism in the transport layer is consisting of port number. Port number is the number through which a particular process is assigned. We have to deal with two port number. One is called source port number, one is called destination port number. As per the International Corporation of Assigned Names and Numbers, different port numbers are classified into well-known ports, registered port and dynamic port. So this is related to the process to process communication and logical link establishment. So we have to discuss about the encapsulation as well as decapsulation. We have to discuss about the multiplexing, demultiplexing. Encapsulation is the mechanism through which certain information added to the existing the information coming from the upper layer, and the reverse mechanism at the receiver side is called decapsulation. And the functional of the multiplexing is to combine multiple packet, and that can be combined and sent through a single frame or through multiple frames, and that reverse mechanism is called demultiplexing. In addition to all these functionalities, other functionalities in the transport layer include flow control. What is the amount of information the sender can send to the corresponding node, and what are the information variables that required to be maintained, like sending window, receiving window, then flow sliding window protocol, different variables associated with the sliding window protocols. That is then the window syncing, window closing, window opening, buffers capacity. All these plays major role while deciding or discussing of the flow control. Later, there are different mechanism, error control mechanism. The most common error control mechanism is known as checksum. In addition to that, also transporter deals with the sequence number acknowledgement to recognize in case of packet loss or in case of some congestion between the in between the two ends, and this all combined together, we can say the flow control, error control and congestion control is the major backbone of the or major functionalities that supported by the transport layer, in addition to the existing process to process communication, flow connection oriented, connection less services, then flow error and congestion controls, then multiplexing, encapsulation. All these things are related to the functionality of the transport layer. So we in the corresponding next video we have to discuss the different flow control mechanism as well as different congestion control mechanism. Just in brief, this is the how processes at application layer to communicate with the corresponding processes in the corresponding application layer, and how this mechanism supported by the connection of logical link. These are the basically role of the transport layer. And as per the classification by ICE, International Corporation of Assigned Name and Numbers, it is the daytime client is assigned with a port number that is 53,000 in this given example, and the server address port number address 13, that is the source port address, and this the destination port address, and data is prepared. Then this data segment is known as segment communicated to the corresponding end. In this case, this is daytime server is one end and daytime client is another end. So when the server send the data, it append its own address, that is which is in this example is 52,000, and its own address is 13 and destination address of the client is 52,000, and this way both way the information takes place between two endpoints, and this type of communication is known as full duplex. That means the information can be propagated from the both direction, and in order to support this process to process communication we need a logical link, and that is done by the help of a socket interface, and for that we have to in the packet must be included some addresses, that what we are calling a socket addresses, which is nothing but the it need to be combined the different address, IP address and port number to corresponding for the particular process IP number, host IP number and process port number. And this is shown in this given example, what we just explained previously. As per the classification, the port numbers are classified as well known, registered and dynamic or private. So the port starting from 0 to 1000 first 10 bit means 1023, that is known as well-known ports, and basically these numbers are assigned to the all well-known applications like HTTP. That port number is required assigned is 80, FTP 2021. That they are coming under well-known ports. In the same way, some of the port numbers between 1024 to 49151, they are known as registered port, or you the application have to register one port number if you want to assign to its corresponding application. And the remaining up to 65,535 number, that is from 49,152 to remaining, that is used for dynamic or private purpose. So for the basic understanding of the socket programming, we may go for any port number between the 49 to 65,535. This is the socket address. Already told that socket address is deals with the IP of the network layer and port of the transport layer. So IP is a 32-bit represented through dotted decimal. Each bit represents 80-bit, whereas the port number is 2 bytes, that is 16-bit. Already the classification we just explained. Well-known port numbers up to 1023, then a registered port number up to 49,151, and the remaining is called dynamic port number, private port number. So this socket bind with port number and port IP numbers. Then this process describe the image describe about the how information communicated between the two endpoints. This is called multiplexing and demultiplexing. Different processes prepare the messages like M1, M2, M3 and so on. In the process of multiplexing, all these messages are combined and placed over transport layer multiplexing unit, and they are communicated to corresponding destination. And in the receiving end, this reverse mechanism of the multiplexing is done by the receiver. It demultiplex it, and once the transport layer demultiplex it, then it send the corresponding message to corresponding processes, so that the end-to-end link and communication is maintained. So this basically is very important communication in terms of packet throughput, all these things is concerned. So basically transport layer deals with multiplexing as well as demultiplexing. And this is related to flow control, based introduction to flow control. There is a sender and there is a receiver, and this flow control sometime may be on demand, or maybe sometime that what is called whenever the consumer or producer sender deliver the information without receiver's requirement or request, that type of flow information is known as push. And when the reverse is that means when the receiver send a request to provide certain data, and that type of delivery mechanism known as pulling. So flow control basically based upon the whether it is requested by the consumer or it is not requested by the consumer, it can be called as push and pull. And in the application, when a connection is established between the two endpoints, basically we need to establish the flow control that between the two endpoints. So here basically in the sending side, the application layer or application protocol compile the message, collect the message, and it pushed to the transport layer, corresponding transport layer. And the corresponding transport layer, after making some necessary changes to the existing message, that what we are calling it is encapsulation, then it send that corresponding segment to the corresponding destination's address, IP and port address, so that destination node can receive that message and properly deliver the message to the corresponding application processes. So if you look at the diagram, you can find a flow control that is established between the application processes of the sender and transport layer processes. This is one flow control, and another flow control between the transport layer of the sender to transport layer of the receiver, and another flow control between the receiver's transport layer to sender transport layer. So this way different flow controls mechanism are maintained, but basically our flow control basically majorly depend upon the end-to-end communication supported by the transport layer. We give more importance to the transport layer flow control rather than application processes to transport layer and vice versa. And these are the related information we have to discuss later. How the sliding window protocol works, how the selective repeat protocols work, how the stop and wait protocol works. This is the example of a sliding window type of flow control mechanism, which deals with different sequence number. Here the numbers represent the sequence number of a particular segment. So there are different variables that it uses, like some packets, outstanding packet, they are communicated but not acknowledged. Some packet are ready but they can be sent but not sent yet, and there is some packet that cannot be sent. So that variable we have to discuss later, no need to read it at this point. Same information is shown here. This 0 to 3 is already outstanding, means already they have communicated, but we are the sender waiting for the acknowledgement. 4, 5, 6 can be sent, so they are in the queue. So we are using outstanding packet and the packet next to sent. But based upon the type of protocol that transport layer uses, you have to perform the action accordingly. If it is stop and wait, then it have to send only one packet. If to go back and protocol, then you have to select the flow window depending upon the number of bits in the sequence number, and so far for selective repeat, where the window size is relatively half than in comparison to GPN, go back and protocol. But whereas there is some little bit difference between GPN and selective repeat, we have to discuss later. So this is the mechanism for connection-less services. Connection-less services does not require any prior establishment of path, because in connection-oriented approach, handshaking is required between the two end systems before communication of the data. So that is the additional delay that required for connection establishment, and then we have to you have to transport the message, and finally you have to tear down the message. But in case of connection less, that mechanism is not required. No need to establish the connection. You have the data, you have to send it, and no need to tear down the processor, no need to close the connections. Connection oriented, just I have told, connection establishment tests or phases, then data communication phases, this one, and third one is connection tear down, or we can say your closing. This is your connection establishment, this is called connection data communication, and this is the tear down. So this basically TCP follow this connection oriented services in order to make the protocol more reliable. This is the different states in terms of finite state transition related to the connection oriented and connection less. Whenever we will discuss the TCP and its states, then this is open wait, closed wait, timed wait, all these things will be more in detail. At this time, just this is the representation how what are the different events occur when a particular action takes place. Suppose when you receive a sync message, what the corresponding action to be done in case of the connection oriented approach. If you are receiving a FIN message, what the corresponding action to be done. So these are related to that services. Just quickly, I want to summarize all these things related functionalities. We discussed the different functionality of the transport layer. We discussed the different services, and we discussed the different protocols. In generalize, transport layer deals with basically two popular protocol, TCP and UDP, transmission control protocol and user datagram protocol. Then two popular services, connection oriented services, connection less services. Connection oriented supported by TCP and connection less is supported by UDP. Then it deals with different functionalities like process to process communication, socket addressing, port addressing, flow control, error control, congestion control, multiplexing, demultiplexing, encapsulation, decapsulation, duplexing, full duplexing. All these are related to the transport layer functionalities. So we have to discuss later which protocol is which functionality, which services used by which protocol of the transport layer. So I think this you understood what I explained, or what is my intention to give a brief introduction to transport layer, and in the subsequent video we have to discuss the remaining things. That means all these functionalities in more in detail that we have to discuss in the corresponding video. Thank you all.